Kia ora. You will very likely get complex ion problems in the exams. They're normally for excellence level, but there are also opportunities for achieved and merit. So I strongly recommend that you practice answering these type of problems. So complex ion problems usually do not involve calculations. In fact, they don't. But you need to explain in terms of equilibria and Le Chatelier's principle. So here's an example of silver chromate is in water, or there's another one with silver chromate and ammonia. Now, whenever you see ammonia or hydroxide, think complex ion. So in the next step you do is you think of equations. So think of the equations so you can discuss the effect of the common ion or the complex ion, and you must explain why the position shifts to the left or the right. So here are the equations. This is the solubility equation, my silver chromate dissolving to form the ions and the chromate, so make sure it's balanced. And this is the complex ion formation. So remember, silver is the exception where it only has 2 ligands instead of 4. All the others are 4. Right, so what you would say in pure water, the silver chromate is in equilibrium with its ions. But when I add ammonia, ammonia reacts with the silver to form the complex ion, which is soluble, so it will go into solution, which means if my silver ions are reacting with the ammonia, it means that they are being removed from the solution because they're changing from silver ions to the silver complex ion. And that means this equilibrium position has to shift to the right to produce more silver ions and more chromate to try and replace the decreasing silver ions. And that means that the silver chromate is going to start dissolving. So make sure you've answered all parts of the questions. Okay, so you've got to explain about the solubility. Compare and contrast the solubility. So it's more soluble here than there. Right, here's another one. And it says, if I decrease the pH of the water, so by adding acid, what will happen to my solubility of my iron 3 hydroxide? So again, think of the equation first. Always write the solubility equation. And now you start discussing what happens. So if I have hydroxide, pH, remember, is the hydronium ion, but the hydronium ion is in equilibrium with hydroxide ions to form water. So if I add more hydronium ions, it's going to react with any hydroxide ions that are present in the water, because water is in equilibrium with these hydroxide and hydronium ions. So if I'm starting to remove the hydroxide, then again in equation 1, the equilibrium position will shift to the right to try and replace those hydroxide ions. It's useful to label your equations as 1 and 2 because it's then easy to explain. So there's going to be a shift to the right, so your iron hydroxide will increase in solubility. And here are the various steps that we spoke about. By adding hydronium ions, it reacts with the hydroxide ions. So the equilibrium position of equation 1 shifts to the right, and that means more FeO3 is going to be soluble. Okay, last one. I've got zinc hydroxide, and I'm going to increase the pH. So remember, write the equation. So zinc hydroxide in equilibria with its ions, make sure it is balanced because it's 2 there, so put a 2 there. Then remember, hydroxide or ammonia is complex ions. I know we had hydroxide in the previous question, but Fe3 plus wasn't one of those complex ions. So it doesn't happen all the time, but usually hydroxide means complex ion. Think of Zac and Zelp, and Zelp is to do with hydroxide, zinc, aluminium, lead. So there are my 2 equations. So basically we're saying in a saturated solution, we've got zinc hydroxide in equilibrium with zinc and hydroxide ions. And if I increase the pH, I'm going to get more hydroxide in solution because I'm adding base, so I'm increasing OH minus, which means initially my zinc hydroxide will precipitate out more. I'll get more of a precipitate of zinc hydroxide because the equilibrium position has to shift to the left to try and get rid of this added base that I'm adding. However, as I keep on adding base, eventually the OH minus is going to react with the zinc 2 plus, and if there's lots of them, and this was not balanced, there should be a 4 there, and that's why you have to have lots of hydroxide present, because I need 4 of them. It's going to form the zinc hydroxide complex ion. And that means I'm taking zinc ions out of that equilibrium because I'm now forming the zinc complex ion, which means in equation 1, the equilibrium position is going to keep on shifting to the right to try and replace more zinc ions that are being used up to form the complex ion, which means that my zinc is going to dissolve. My zinc hydroxide will dissolve. So we say initially I'm going to get more of a precipitate, and finally, when I have enough OH minus, I'm going to form the complex ion. So I'm going to actually get my zinc hydroxide dissolving. So think of all these tips to try and answer these questions. All the best. Kia ora.